Hey everybody, welcome back. This is lecture 20. We're going to talk about analyzing text. We've already seen a little bits and bobs of this throughout the course, but this time we're going to get a high concentration dose. This goes on nominally for 2 classes. It's not quite that, but I'm going to stretch it out for that. And I think that you're going to be excited because, of course, a lot of the kind of fun we've already had talking about things like Twitter analyses, we're going to get into a lot more detail on. But before we go that way, let's get into the logistics. In fact, oh yeah, that's still never fixed that. All right. So, important announcements. The guest lectures are live and they are set. So there is not going to be a guest lecture on Wednesday, whatever the day that is, the 25th, right? So there's not going to be a Wednesday the 25th guest lecture. Instead, we're going to have guest lectures on November 30th and December 4th. So that's a Monday and a Friday of the week after Thanksgiving. Okay, that also means that some of the lectures will move around, but, I think we're all flexible. The important part is that the guest lectures are live. So you will get participation points for showing up, and yes, I will know if you were there, and I will also know if you left after 2 minutes. But more importantly, these are super awesome opportunities that people in your circumstances rarely get. So I think that you can learn a lot from our guests. Before we get into who the guests are and what they do and why you want to come talk to them, I want to just mention that we have the algorithms reading, which is due, it's going to be open so it's the usual thing, it's going to be open Thursday and Friday for you to take the quiz on. And then the week after is going to be assignment 3. And then know that the midterm is coming on Monday, December 7th. So that's in the order of 2 weeks away. Just to put that in your mind. And there will be a couple of class periods beforehand. There will be an exam review to help you out. Okay, so drum roll please. Who are our guest speakers? Well, guest speaker number 1 is Ben Welsh. He is the editor of the Los Angeles Times Data and Graphics Department. So he is in charge of a team of reporters who are out there making these cool infographics that you have seen, and sometimes doing some very deep data science-y analyses of data in order to follow a story. So he's also a big open source and open data kind of person who runs a civic data coalition. And just generally, if you wanted to find out about the idea of using data science for the public good, this is a man who's been involved in that. So I highly recommend that you take a look at some of the things that he and his team have done over the years. These really incredible infographics, for instance, recently on voting, or on coronavirus. So this is, like the tiers that we've been in. So the purple tier, the red tier, the orange tier with each county. These are pretty cool kinds of things that these teams have to do, not just, awesomely, but within hours oftentimes. So Ben knows a lot about graphics. He knows a lot about munging, difficult data. And he knows a lot about hiring people who do those kinds of things, and about people who, what the paths forward might be if you're interested in careers in data science journalism, or just generally in data science for the public good. So guest speaker number 2 is not 1, but 2 guest speakers. So Jacqueline Nolis and Emily Robinson are both, mid-career data scientists. They've both been around for like a decade, working in a variety of different companies. So Emily works for Warby Parker. I need new glasses. Maybe I'll talk to her. And she used to be at Data Camp. So she's done a lot of things through her career. Jacqueline is also, she's a higher level mathematics kind of person, a PhD, and has worked in financial industry as well as nowadays in marketing. Okay, so, but that's not why I have them on. They will definitely talk about their work experiences and all that kind of thing. But the reason I'm having them on is they are co-authors of a book called Build a Career in Data Science. And having taken a look at this, I was pretty impressed. Okay? What it covers is all the soft skills that academic courses like mine are not going to teach you. Right? How do you do the things that get you a job? Things like interviewing stuff, things like, making a portfolio. How do you evaluate your job? What do you do as you're settling in, trying to make a place for yourself? How do you get people to buy into your projects? How do you know when it's time to leave a job because stuff's gone in the toilet, right? I mean, really cool, good career information. So I think that this is really exciting from my standpoint because it's exactly the kind of thing I can't give you. All right. So again, November 30th is Ben Welsh talking about journalism and data science. And December 4th is going to be Jacqueline and Emily talking to you about both their careers and cool things they've done, but also about your career. So please come to these live Zooms. There are going to be short presentations by these people, and then there's going to be a lot of Q&A, because I'm pretty sure you would like to learn things from people in these situations. If you have questions that you would like to ask and you cannot make the presentation for some reason, please do submit your questions to me, or actually do it on Piazza. Okay, do it on Piazza. That way we can run it more easily. All right, let's do some text analysis. So today's objective is we're going to look at all these different analytical applications with text. We're going to discuss the ways in which we can do text analysis, and also the fact that mostly we can't really understand natural language, in spite of great strides made by cool deep learning networks. They don't actually understand human language. They just process elements of it. So there's always a limit with this kind of stuff. We're always doing something clever rather than exactly what we want to do. All right. So first we're going to lead off with a little bit of the basics of the beginnings of all natural language processing pipelines. That, by the way, is that natural language processing. Okay, that is an abbreviation that will turn up a lot here. We're going to talk about sentiment analysis, which we've already done in previous courses a little bit. A method for measuring how interesting and unusual words are in a given context. And then we're going to talk about visualization and everything that you would learn in 2-3 years of study in just a couple of slides on the back side. Okay. If we're going to work with words, we have to start with the fact that they are composed of letters. And what we get when we work with data about words is strings, which are just sequences of characters. Now the problem is, to understand language, we have to take those strings of characters and figure out where's the units of meaning. Okay? Units of meaning kind of vaguely start with words, although not totally. okay? But if we want to find words inside a data string, we have to chunk them up. We have to create tokens, is the word we use. We're going to take the string and split it into tokens. There are a lot of different ways to do this. There are as many algorithms for tokenizing as there are game tokens from video arcades. Now that's a reference that dates me, sorry. All right, so we're going to tokenize these words up. Now, as this little slide here alludes to, if we start with a tweet in this case, okay, and we need to split it up into things. We have a lot of different ways to dealing with that, okay? The dumbest thing, the one you and I can program in 6 seconds with Python, is we're going to split it on white space and punctuation. So the assumption is that if we have a string of sentence, encoded in a bunch of characters, that words are broken by spaces between them, and sometimes by punctuation marks like periods. Okay? So if we do stuff like that, then we do end up in some problems. Like when we look at, worlds problems, which is, where is that? Already lost track of the, right here in the tweet, right? The world's problems. So if we break it up that way, then the apostrophe S becomes its own token in Word. Okay, sometimes you want that. There are various algorithms that kind of depend on that. And there's others that don't, where you would like to know the world's apostrophe S, right? So there are other ones which don't break things up on apostrophes. So, do they handle funny, weird things like emoji or not? How do we break this up in a general purpose way? There's no one right answer. And some of these different tokenizers are going to do things that don't make sense for a human, where we go, this is not a word, this little piece, this apostrophe S. But, sometimes natural language processing algorithms have come to depend upon that. All right. The exact way we do it is going to be dependent upon your goals and what else you're using in this NLP pipeline. But just for right now, realize that it's not an easy problem how to break things up into words. And once you do have words, you maybe don't necessarily want the actual word, maybe you want its root. Okay, so think about the rap stuff that we were looking at before, right? The hip-hop vocabulary. So does play, playing, plays, played, right? Are these all the same word? It's all one common root, right? So how do we count the vocabulary of somebody who says, you got played, you're playing around, blah, 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 in a song? Well, you got to decide. Are you counting playing and played as separate words, or are they all just from one common root, play, and we're only going to count one new vocabulary item? So whatever it is, if you are going to go for the root, there are ways to go ahead and pull that out. So stemming and lemmatization are two related but different ways to go about that. And what they produce is this kind of, this is just the perfect subjunctive form of the verb. I do not remember what that means, by the way. I just, some terminology from my last language arts class in the 10th grade. All right. So one of the cool things about that is that if you had something like the boys' cars are different colors, and you standardize it through lemmatization, it would come out as the boy car be different color, the most rooted form. It makes no sense to a human, but it's a more machine operatable version of this sentence. Okay. So let's run an example real quick to give you an idea of how this works. So if you follow this link on your own time, you can see some interesting papers where people have used natural language processing to try to figure out interesting things. Okay? I'm just going to very quickly read you a little bit of this. So I don't know how much background you might have in forensic stylometry. The basic theory is really simple. Language is a set of choices. Speakers and writers tend to fall into habitual or at least common choices. So this is the reason an Englishman drives a lorry, but an American drives a truck. It's a dialect thing. And sometimes there's social pressure. If I need to impress somebody with my vocabulary, I can utilize a polysyllabic lexicon instead of just using big words. Okay? So, so some of this stuff is like, is always going to be there, even when you're not paying attention, right? So things like, do you place your fork to the left of the plate, or do you place it on the left of the plate, or do you place it at the left of the plate? Okay? These things are going to operate on a subconscious level, and your word choice is going to be indicative of who you are, and it's going to be hard to change in some fashions. So, so this person got a call, the person writing the article got a call from a reporter asking to assess if this mystery writer Rob Galbraith was actually J.K. Rowling. Okay, he'd gotten an anonymous tip that it was, and he needed some analysis to find out if true. Okay, so what they did is they took copies of writings by J.K. Rowling when she was writing mystery, which is the category that the Galbraith books are, right? And she also needed to have other authors who are also writing similar mystery kinds of things. So she had samples from P.D. James and Val McDermid and a couple of other authors. Okay? So breaking the books into chunks of 1,000 lines and comparing the vocabulary of each of those chunks and looking for systematic regularities, right? So things like, how long is the average word length? Okay? Things like, what else was on? What percentage of the document was made of function words like the and of and so on? Okay? These kinds of ratios, simple measurements of just counting words and then in the end she gets a vector representing each one of these chunks of 1,000 lines. How many the words is one entry in the vector? Okay? And then she can look at the difference. So like compare vector 1 to vector 2 and see, do these things look more like the works I have of J.K. Rowling, or do they look more like the works of P.D. James, who's another mystery writer? Okay? So comparing these kinds of things showed in the end that J.K. Rowling was the most likely author of this Galbraith book, much more likely than the other 4 authors they had samples from. Okay? It's not a slam dunk, but it was highly suggestive. And then in the end, J.K. admitted that this was her work. Okay? So looking at most common words in the text, distributions of word lengths, distribution of character foregrams, and word bigrams. So a gram is a word. Okay? So a bigram is chunks of 2 words together, like thank you. So we can measure the occurrence of thank in the text, or we can measure the occurrence of thank you, which is a bigram. And a foregram, I think you can guess what that is. Okay? So these are simple measurements. We can mathematically manipulate them once somebody's given us a good data set and come up with similarities between the different example texts we had and this unknown text. So that's the kind of thing that we can do. Now you've already seen sentiment analyses, at least a little bit, but the idea is, of course, that we're going to infer the emotional content of the text. How do we do that? We need to first tokenize and stem if we're going to do that. And then we have it, just this bag of words is what it's literally called, okay? We take, for all the unique words in the tweet, if that's what we're doing is Twitter, okay? We just have a representation, which is like, is this word in it? Yes or no, okay? So we need to compare each one of those words. We don't care about their order, right? It's that car boy sentence thing, right? We don't care about anything about their actual meaning. We're just going to take words, and in a given chunk, we want to compare them against a lexicon, which is like a dictionary, right? A lexicon is a data set which has words in it, and we can look up whether those words are thumbs up or thumbs down emotionally. All right, so here's an example. Okay, if we have a lexicon that has things like abandon in it, so it's going to have sentiments of fear, negative, sadness. Okay, so we get the word abandon in our tweet, and we're going to add +1 to fear and +1 to negative and +1 to sad. Now, does anybody see a problem with this approach? Anybody? Yeah, James Earl Jones. You're right. It's not always the case that, okay, so Mr. Earl Jones in his very nice voice has made a great point, and it's a shame it was too far off mic for you to hear, that, these words don't always mean only one thing. For instance, abandon here is uniformly a negative kind of thing. But if you think about it, you might have heard a more poetic use of the word abandon, to leap about with great abandon, right? It basically means to not abandon hope or something like that, like you might think, but it means to abandon self-criticism and, normal rules of behavior and just going for it. Yeah, it's going to go for it. I'm going to go with abandon. I'm going to abandon all of my my inhibitions. Okay? So in that case, that kind of abandon would often be a positive word. So we know that things are going to be different with different contexts. And that is a common theme in language processing. And we may not always get the right context. And in cases like this, we don't even try. So when we're doing sentiment analysis, the two things is that we've got to tokenize up. We've already talked about splitting it up into tokens, and those tokens could be individual words, thank, or they could be bigrams, thank you. Okay? And we're going to count them up, and we're going to look up those tokens in our lexicon and increment our counters of positivity or negativity according to what we find. Now, we also have these things called stop words. Stop words are not helpful. So nobody cares about the and of and to, and we just need to throw them out generally. And that's what a stop word is. It's something we stop using and throw out. So here's a quick example. If you remember during the student survey, in the midterm, I asked you, what have you most and least enjoyed so far? Well, we can do a sentiment analysis using an established lexicon that's, available freely on that text. And we can find out, was there a match between the least enjoyed and most enjoyed and their sentiments? So the least enjoyed comments, your several hundred of them, are all in the red here. So if you look at the red, there we go. All right, so if you look at the red bar here, the positive bar is relatively low compared to the most enjoyed in COGS9 so far comments. So clearly the most enjoyed comments do have a positive affect compared to the least enjoyed elements of COGS9. I hope that's true. You can't see because it's behind my head, but the reverse is true over here in the negative case, where the least enjoyed are higher than the relatively small most enjoyed. So overall, this seems to hold. Joy is much more prevalent sentiment by this lexicon in the most enjoyed. That seems to be kind of, what do you call that, a tautology? More joy in the most enjoyed. Okay, you get the idea. It seems like this kind of sort of works, but if you recall the abandon problem, it's weird, but yes, we find some positive sentiment in the category of the things you least enjoyed. Okay? These are rough tools. They do just about a good enough job. But that's okay. We will keep on using them. Okay, so that's about as far as I wanted to go right here. I want to keep on with my breaking it up into smaller chunks so that it's easier for you to watch. I hope you all will come back and tune in again in just a few minutes. Bye for now.